Alright, so now we are starting part 3 of the Tagger tutorial series. So this one, I'm kind of planning on getting into the Tagger query language, so it might get kind of long. I apologize in advance. I spent a lot of time thinking about how I wanted to create the query language and spent a lot of time implementing it. I'm really quite proud of it, to be honest, so I might talk maybe too much about it. Um, but I like it a lot. So um, we'll go back. We'll go back to my database here. Just as an example, I don't know. Maybe I'll bring up some code or something for you guys to look at if I feel so inclined. But for now, what we'll talk about here is the basics of querying with Tagger, right? So there are maybe two major things that are important when you're querying for files with Tagger. So number one is what you're querying for. So this is called the query criteria. So you can search for tags that are on a file. You can search for the file path or the file pattern, as it's called, the pattern. You can search for untagged files, files that have no tags, of course. And then the last thing you can search for are relations. And so relations is really kind of, I don't know, maybe it's a little bit silly to say, but it's kind of a legacy thing. But when I say relation, I really mean meta descriptors. So you can search for meta descriptors. So those are the four main query criteria. And so those are important, so remember those. And then of the two things that are important for the query language, there's another thing which you can see in this drop down here. So this is called the set op, or the set operation. And this is how your queries are combined with each other. So queries in Tagger are basically just hash sets of values, and you combine them using common set operations. So you have union, you have intersect, and you have difference. So those are important. Those are how you combine, how you kind of drill down or whittle down your results of your query. So those are important to know as well. Those operate exactly how you would expect them to work, right? For unions, intersections, and differences for a given set of things. So with those two kind of main concepts, we can start talking about how the query language works. So maybe the first thing that we covered in the first video are untagged files. Those are kind of outliers in the query language, so now that I think about it, I might actually come to those last. So what we'll do first is just tags, right? Because this is a tagger, so you want to be able to search on the tags that you've made. So we have these tags here, which we can see right now with our very own eyes. We can see these tags that are here, and we can assume that since they exist, that there are images that have these descriptors tagged to them, right? So if we wanted to find those images, how do we want to search for them? So the Tagger query language operates on pretty much two kind of distinct tokens. So we have our query criteria token, and then we have our actual pattern token. So if you remember our query criteria, we have descriptor, we have pattern, we have relation, and we have untagged, and those are our four query criteria. So the query language requires one of those, at least one of those, to figure out what you're trying to search for, right? So if we want to search for a single tag, say that we want to search for something that has this tkmiz tag, right, and only this tkmiz tag, what we want to do is type d dot, and this can be capital D dot, it can be lowercase d dot, it has to be one of those. And then without spaces, we have to give the name of our tag. So that this d dot is our query criteria, and then anything that follows it is the pattern that we want to search for. So we're telling the Tagger language to search for a descriptor that has the name tkmiz. And this can be done with SQL wildcards. So like, maybe if you're like me and you're kind of too lazy to type it out, you just want to type tkm and then just do a %. So we can do that. And then in this query bar, you just press enter. Yeah, nothing shows up because I don't actually have anything tagged as tkmiz. So we'll try a different tag. So we'll do D dot, and then we'll just do tanned. How's that? Search that up, and there we go. We've got this one. We've got Momo right after she got her tan, and that brought up this other file here too, the second one. So we'll scroll to that one here. This, you know, if you're familiar with the fossil database, you've maybe seen this one before. So that's how you tagged. So that tanned descriptor, when we searched for it, brought up both of these images because they have this tanned tag here, right here, and then in this other one it has this tanned here. And this is another important point about the tagger query language, is that most queries are flat. And when I say that, I mean that we have this tagging structure here, which has these kind of nested tags, right? So we have this Momo tag, and then we have in that tag we have these subtags. So we have these 2/3 determined, star people, and tanned. So those are nested inside the Momo tag. But when we do a descriptor search for tanned, it's completely flat. So it doesn't care if it's nested, it doesn't care if it's not at all. It'll search for any image that has this tanned descriptor applied to it, which, since this tanned, even though it's a descriptor of Momo, it's still applied to this image, so it'll pull this image up for us. And we can see that same thing, right? So we can disassociate tanned with Momo, so we can see that tanned is now just a standalone tag. It's not a subtag of anything. And we'll go ahead and clear this here. I'll just query it again. We'll do that. Hold on, I did something wrong. D.tanned, like so. And here we can see it brought up that image again, and we're on that same image, so we can see it there. So it's the descriptor queries are completely flat, right? So it doesn't matter how many layers a descriptor is nested in. If it is tagged to the image at all, it'll appear in the query. So that's an important point to understand about how these queries work, right? So then, you know, what we could also do is next we'll talk about file pattern queries. And so we've talked about descriptor queries. Now we'll talk about pattern queries, and those are matched on these file patterns here. And you can use SQLite wildcards for these as well, which is usually what I find easiest to do. And the tagger query language tokens for those, instead of D dot, we use P dot. So, you know, P for pattern, of course. And then say if we want to find every image that's in this Machikado folder here, oh my gosh, we can just type that in like that. We have to use our wildcards, otherwise nothing will appear, because there are no files that are just called Machikado. But we want to match anything that has this word appearing in it, right? So we do that, and then now we've got every image that exists in that Machikado folder that's inside the database. So there's 1,300 images in there. Right, so we've got all these. So you can see how that works. So that brought up everything inside that folder, and that's what that P dot token does. Is it tells Tagger that we want to search for a file pattern. So this ignores descriptors completely. We can see also that there are, I don't know if we'll see any, but there are definitely some images here that don't have any tags, like this one. So P dot ignores image. It doesn't care about tags at all. If an image has no tags, it'll show up in when you do a P dot search and everything, right? So we'll go ahead. We can clear our selection with this button here. That'll clear everything. The image that's in focus stays in focus, so that doesn't ever go away. So you can even tag this image if you have nothing in the selection. You should be able to tag this too, right? So I can tag this with Hinatsuki because she's in this one too, so we can do that. Let's see, next we will talk about our relation query, which is important. I talked about this in part 2 with our meta descriptors. So we have all of our meta descriptors here. A relation query is a way to query with meta descriptors. So relation queries are like descriptor queries in that you search for descriptors with them. But in a relation query, you not only search for the descriptor, but you search for every descriptor that is infra to that descriptor, right? So we have like this tand descriptor here. We originally did a d dot tand. If we want to do a relation query, we do r dot, or you can do capital R dot like that, right? And since R dot will search for both the tand descriptor and any descriptors infra to it. Tand doesn't have any infra descriptors, but we can still search for it, and it'll still bring up the descriptors that have tand in them. But the real power in using a relation query is when you want to use one of these meta descriptors, right? So if I want to find every image that has a character in it, I can do r.character, and that'll pull up every single image that has a character in it, right? And you can see there's quite a lot. Quite a lot of different characters in here, right? So that is you know, simple but powerful to know. And this is why it's useful to group things in terms of meta descriptors. So now, if I only want to see characters from a certain show, I don't have to do a pattern match for that. I can just do one of these, right? And that'll bring up all of the characters from Idolmaster, and I didn't have to do a pattern match on the actual file structure, just in case, you know, like we see here, I have some files that, you know, maybe reside in a different folder, like that. And here we can see this is my desktop wallpaper and stuff like that. So this is why it's useful to group as meta descriptors. So maybe this is evident to you. I thought it was a very cool idea, and I think it's very helpful. So let's see. And also, an important note to say is that if you don't have this r dot, if you don't have one of these tokens, then Tagger assumes that by default you're doing a relation search. So you can search without an r dot, and Tagger will assume that you're doing a search for all of these characters like that, right? So that's an important note. So you don't need to have a token before every query turn, but if you don't, then Tagger assumes that you're trying to find a relation, or you're trying to query on a relation. And then now for the last part about this, and I'm thinking now as I do this that I might break this up into two different parts, because this is kind of a beginner tutorial. The Tagger language has some advanced syntax, advanced features in it that are very useful, but I'll get into those next video. But the last part, the last query criteria to talk about is the untagged criteria. So this will search for any file that doesn't have a tag applied to it, and we use that, which you saw this in the first part, is u dot. And so u dot by itself is the token. The actual Tagger language parser that I wrote, after any given token always requires at least one character after it, so that's why I said in the first video that you had to write u.a. That's not actually true. You can write anything after it. It just has to be some character. Otherwise, if you just do nothing, then nothing will happen, and we can see you get a parse error after that. So that's kind of a bug, something I've kind of intended to fix. So we can just do u.a, and that'll bring up every file that I have in the database that doesn't have any tags on it. So we have a compromising picture of Komari in there. But we've got all these in here. And that'll bring up all the ones that are untagged. So there's the basic tutorial for the Tagger query language. So just remember d dot for one single descriptor. So like I can do d dot these, and I don't have any images tagged with just that descriptor, so it brings up nothing. And then the next one is p dot, which is file pattern. Then the one after that is r dot, which is the default, and that'll search for meta descriptors and anything that's infra to it. And then the one after that is just u dot followed by any string, and that'll just pull up all untagged files. Right. So that's the important thing to remember for the basic overview of the Tagger language, and that's enough really to get you started. Honestly, you don't need any more than that. But the advanced features are very helpful, and you know, I would be maybe kind of disappointed if you didn't use them, because I thought they were very cool. So thank you.